The series n squared over 2 to the n, where the a sub n term is n squared over 2 to the n. In general, if the n power is present in the a sub n term, we use the root test. The n root of a sub n is the n root of n squared over 2 to the n, which is the limits at n go to infinity of n to the power 2 over n over 2. But the limits at n go to infinity of n to the 2 over n, in the continued version, it is the limit of x go to infinity of x to the 2 over x. And we rewrite it using ELN. Move the 2 over x to the front of the ln, and then we use the L'Hopital rule. The derivative of the numerator is 2 over x. The derivative of the denominator is 1. The limit is therefore either 0 or 1. But the limit of n to the 2 over n power over 2 is 1/2 the limits at n go to infinity of n to the 2 over n. This limit is 1, so the result is 1/2 times 1, which is 1/2. This is less than 1, so by the root test, the series converges. The series 2 to the n over n cubed, where the a sub n term is 2 to the n over n cubed. We notice that since n is in the power, we use the root test. The n roots of 2 to the n over n cubed is 2 to the n over n over n to the power 3 over n. But 2 to the power n over n is 2, and so this is 2 times the limits at n to the negative 3 over n. But the limit at x goes to infinity of x to the negative 3 over x can be evaluated using ELN. We move minus 3 over x to the front of ln, and then we use the L'Hopital rule. The derivative of ln of x is 1 over x in the numerator, and the root of x in the denominator is 1. At x goes to infinity, minus 3 over infinity is 0, so this limit is 1. So the original limit is 2 times 1, which is 2, greater than 1. So by the root test, the series 2 to the n over n cubed diverges.